Hi, this is going to cover 11.8, which is over samples and surveys. And the first thing that we're going to cover is the sampling types and methods. So first of all, you need to know a couple words, and I just printed this out of the book. The word population is all of the members of a set. So everyone is the population. A sample is part of that population. So a lot of times when we're trying to figure out whether something is um, uh, like to take and so for example, if I want to know if my chapter 11 test is good, whether or not it is too hard or one question's too hard or something like that, I can look at my whole population, so everybody who took that test, or I could just take a sample of some of those students and look over their tests. So you can get, let's say if we wanted a general idea of everyone in the United States, we aren't going to be able to get the whole entire population to answer something. So we would need a sample of that population. So that's the kind of idea here. Okay. The first kind of sample that you can get is convenience. You select any member of a population who are conveniently readily available. So who will answer your questions? They are convenience samples. Self-selected samples is where you select only members of the population who volunteer for a sample. So they self-select themselves. So convenience, you conveniently select them. Self-selected would be they are choosing to participate. So convenience could be I survey everyone who walks in the door today. There's convenient, they walked in my door. Self-selected, I could send an email out in mass, and whoever answers it is who I am going to take my sample from. A systematic sample is where you order the population in some way and you select in regular intervals. So it could be you look through the phone book and every fourth person you call and get their sample. In a random sample, all members of the population are equally likely to be chosen. So you have the whole population, you're randomly sampling from that whole population. Also with this comes the idea of bias. So a lot of times when we are doing statistics, we are having a biased sample. And bias is a sample when part of the population is overrepresented or underrepresented. Bias is in the error of this is an error in the sampling method. So a bias is an error in the sampling method. The thing about bias is you could probably find a bias in almost every single type of statistics and sample. So the best sample is usually systematic samples, but let's go through some examples of some samples and be able to know whether they're biased or not. Almost always we can come up with some way it's biased. Okay, here's my first example of sampling. A newspaper wants to find out what percent of the city's population favors a property tax increase to raise money for local parks. Okay, so a newspaper wants to find out what percent of the city's population favors a property tax increase to raise funds for a local park. Okay, so let's look at all right, let's look at my first one from this. What if we put in the newspaper an article on the tax increase and invite readers to express their opinion on the newspaper's website? So what kind are we doing with this one? When we're sending something out in the paper, well, we put it in the newspaper first of all, and then what are we going to get? We're going to get self-selected sample, right? Because they're choosing to write into that website. Is this going to be bias? Well, doesn't it depend on who answers? So it could be bias, but it really depends on who answers. It could be, what if everyone who answers loves parks, then we are overrepresenting the people who use those parks, okay? So the next one, a reporter interviews people leaving the city's largest park. So this reporter stops and they interview everybody leaving the park. What kind of sampling is this one? It's convenience. All right, is it biased? Well, kind of. You're overrepresenting anyone who goes to the park. These are probably the people who would be for a tax increase for that reason. You're definitely not getting people who don't use the park by being in the park. So you're overrepresenting park supporters. Last one here. What if you have a survey, service calls every 50th person in the local phone book? So every 50th person is going to get a phone call. What is that? It is a systematic sample, which is typically the least biased. Well, I guess the random sample too can be pretty not biased. But really, is it biased? Well, doesn't that depend on who answers? If they're over or underrepresenting a certain population? Maybe every 50th person happens to hate parks and sits on their Katushi every day and never uses them. So they don't want their taxes to go up. So it kind of depends for that one. All right, so those are my examples of sample types. Okay, that's gathering your information. What about study methods? These are ways to collect the sample. So let's look at this. Different types of study methods. The first one is an observational study. So studying is where you're looking at something, right? Studying, coming up with something. So in an observational study, you measure or observe members of a sample in a way that they are not affected by the study. Controlled, so observation. Maybe I stand on the corner and I watch the cars go by to see what brand of car people are driving the most, right? That's like observation. I'm sitting out there, I'm not hurting anyone, and I am observing people driving by. In a controlled experiment, you divide the sample into two groups. You impose a treatment on one group, but not on the other control group. Then you compare the affected on the treated group to the control group. This is super common in science, right? You have two groups of people, one you give a drug to, one you don't, and you see how that all had the same problem. We do see that a lot. So you can compare them. In a survey, you ask every member of the sample a set of questions. Every member of the sample is given a survey. So let's again look at some different things. So which type of study method is going to be described in each situation? Should the sample statistics be used to make a general conclusion about the population? All right, so again, we're talking a sample of the population. Can we take this sample and say, okay, this is probably true for everybody? All right, that's what we're asking in these questions. Here's our first one. Researchers randomly choose two groups from 10 volunteers. Over a period of 8 weeks, one group eats ice cream before going to sleep, and the other does not. Volunteers wear monitoring devices while sleeping, and researchers record dream activity. We're trying to see if ice cream affects your dreams, right? What type of study method is this? It is controlled, right? Because we took and divided into people who ate ice cream and people who didn't. And would you say from these 10 volunteers that you could then say this is true for everybody in the entire world? Well, let's think. 10 compared to all the people in the world, it's not a very good sample size. So I would say it's a small sample, which makes it unreliable for a general conclusion. Okay? There could be other things that make it not very good to make it over the whole population, but 10 people is definitely not a very big sample size. Definitely not um, something you want to generalize on. Here's another example. Students in science class record their height of a bean plant as it grows. Oops. So they're recording the height of their bean plant. What kind is this? Experimental. Oops, I mean observational. It's an experiment. So I thought in an experiment um, where we're just watching it is the observational study. All right, and what would make this bias? Not bias, I guess. How would you want to use this on all the population of those bean plants? Well, one thing to consider is there might be other factors like everyone used the same soil type and the same sun and water in the classroom. Like usually the teacher bought one bag. So you might have a better dirt somewhere else or better sun. So you have other factors that might affect it. So that's something to consider. It might not be bad for the overall population, but be aware of other factors. All right. Student council members ask every 10th student in the lunch line if they like the food. You're asking every 10th person. This is a survey, right? If you're asking them to answer certain questions and you happen to ask every 10th person, well, should you make the general bias or the general conclusion about the whole population based off the people in line to get food? Well, probably not. I wrote down the results are not reliable because people waiting in line are more likely to enjoy the food, right, than someone who brought their own lunch. So you should probably have asked people who brought their lunch along with people in line, not just everyone in line. So anyway, this is kind of going to give you an idea of samples and surveys and the different types and how to look for biases in statistics.